Welcome back to Nick Does Maths. Today we're going to be looking at some combinations of random variables. I'm a big fan of this idea. We've got families of normal distributions. X is a normal, mean 100 and standard deviation 5, and Y is a normal with mean 90 and standard deviation 3. There we go, lining that one up. Where you got loads of Y's. So first thing we want to do is X plus the sum of 3 lots of Yi has to be bigger than 390. So let's have a look. See, well, this is a normal distribution because there's a combination of normals. So it's a single value of X and 3 different values of Y. So their mean will be the mean of X plus the means of the Y. So 100 plus 90 plus 90 plus 90, which I do believe is 370. And again, what do we do with the variances when we add normal distributions? We add them. So we're going to add the variance of 25, add the variance of 9, add the variance of 9, add the variance of 9. So 25 plus 9 plus 9 plus 9 is 52. Is that right? 25 plus 3 times 9, I do believe so. I'm not checking that on my calculator, cool. Right, so time for some normal NCD, lower. So we want bigger than 390, upper, something huge. Square root of 52, 370, and ooh, get something relatively small, 0.0028. There we go. Now, conversely, seems similar but isn't quite. This is a single value of X plus 3 times a singular value of Y, which is very different. So the mean of 3y will be 3 times 90, plus the mean of x, that will still be 370, so that's okay. The variance, on the other hand, will become the variance of x, plus now 3, that will be 3 squared for 9. Why? Because variance is squared. So if I scale every single value of y up by times 3, the spread, the variance, which is squared, gets multiplied by 3 squared. And that's the big difference here, because it will be 9 lots of 9. Okay, and 9 lots of 9, 25, oh, wrong one. Okay, it's 106. So we have almost over twice the variance here. Why? Because each of these values of y, one might be a bit too small, big, to the other one too small, and they might cancel out. So it keeps the variance a bit more tight. Whereas here, 3 times y, as soon as y is a bit too big, that is amplified by a factor of 3. So that is why we get this difference here. So all I need to do is change this. So now I need square root of 106, and I will get 0.026. So it's much more likely. Why is it more likely? Well, there is a much bigger spread. Okay, so if the values of x plus 3 are more spread out, you are more likely to end up in these big values bigger than 390. So that is why. Now let's have a little look-see here. X minus y, well, that will be a normal distribution. The mean will be the mean of x minus the mean of y. 100 minus 90 is 10. But we still add the variances despite the minus. We will still add the variances. So that will be 25 plus 9 is 34. Okay, because it doesn't matter if you're adding or subtracting y. The point is there is going to be some variance in x, there will be some variance in y. So when I do any operation with them, those variances, those errors will combine. And now we probably do need to have a little look at this, but all this means is that modulus is x minus y itself is between 4 and minus 4. And plug all of that in, and I get 0.1436. Very nice. Thank you for watching, everyone. I enjoyed doing that. Nice, clean little bit of probability. Tune in next time for more here at Nick Does Maths. To do that, please like the video, subscribe, hit the notification bell button thing, YouTube technology, so that you know when the next video is, and I will see you there. So from me, see ya.